right? In this class we will see minimum mode timing diagram of 8086 uh, microprocessor, right? So in 8086 microprocessor, this is the timing diagram of timing diagram of 8086 microprocessor in minimum mode configuration. Minimum mode configuration, right? Minimum mode configuration, right? You can see here right timing diagram. Right timing diagram. Why I'm call it as a right timing diagram means, while performing data transfers using 8086 microprocessor, four possible things is going to be happen while communicating with external peripherals, right? So in which one is the memory write operation, another one is the memory read, and IO read and IO write, right? So for example, this four is going to be happen memory read, write, right? In the similar way, IO read and write operation, right? Operation. Now I am going to discuss how timing is going to be provided while doing this particular operation, while doing this particular memory write operation, right? So while doing memory write operation, how processor 8086 is making this particular signals coming out from the 8086 microprocessor, right? So all the pins are there, address pins are there, right? Data pins are there, right? Control pins are there, right? All pins are going to be out data in synchronization with clock, right? That means what? With respect to timing of the clock, these all signals are going to be make it 0 or 1, right? So to perform this particular memory write operation, that means processor want to write some data into the external memory, right? To write this particular data from internal processor to the external memory location, all right? So it needs to be out some signals with respect to the clock, right? That's one you going to call as a timing diagram of 8086 processor in minimum mode configuration for a write cycle, right? Operation, right? For write operation, how these particular signals with respect to this clock, how these particular signals are going to be out. If you draw that as a graphical representation, that is going to become the timing diagram for the write cycle, right? So we previously also we have seen in the minimum mode configuration, right? To communicate processor to the external memory, these things are going to be happen. Chip is going to be selected, as well as memory location, that means register, one register among the memory is going to be select using address bus, and second thing, it's going to be out in control signal, right? Then it's going to be make data transfer, right? These three things are going to be happen. To perform this particular one, address bus is going to be used. To out this particular control signals, it's using control pins. This for the data transfer, data bus is going to be used, right? So for addressing as well as the data, we have a multiplexed address and AD0 to AD15, as well as A16 by S3 to A19 by S6. These pins are going to be used. These 20 pins are going to be used, right? These 20 pins only going to be used for addressing as well as as a data bus. So this is demultiplexing is going to be takes place with ALE signal, that right? That's already we discussed in the minimum mode configuration. If ALE signal is high, then it's acting like a address bus, right? If it is 0, it's acting like a data bus. So anyway, control signals are going to provide the control pins are going to provide the control signals. Now let us see now with respect to timing, how these particular signals are going to be high and low, right? If you draw that one for write cycle, right? That is going to become the right timing diagram, right cycle timing diagram, right? So you can see for every t state, that means what, to read data from the external memory to the processor, or to write data from processor to external memory, or to read data from the input device to the processor, or to write data from processor to the output device, processor is going to be take 4 t states. Processor is going to take 4 t states, right? So one, if this timing of one t state is going to be depending upon the clock frequency. Depending upon the clock frequency, the timing is going to be takes place. For example, this clock frequency is 10 megahertz, then 1 by 10 megahertz is going to become the 0.1 microsecond is going to become the timing of this particular clock, right? Time period of that particular clock, right? So like that, for every cycle it is going to take 0.4 microsecond. That means what, within 0.4 microsecond, if it is write operation, write will happen. If it is read operation, read will happen, right? You can see here with respect to this particular timing diagram, how this particular control signals are going to be varied. How this particular control signal is going to vary. See, look at this particular address and data bus. See, this 16 lines are there, right? This 4 pins are there. This is the 16 pins are there, right? These 16 pins are multiplexed with the data. These 4 pins are multiplexed with status, right? A16 to A19 is multiplexed with status, right? So A0 to A15 is multiplexed with data, right? So during the T1 state, during this particular T1 state, during this particular time period, ALE is going to be high by the processor. During that time, these 20 pins are used to carry the address. That means what? By the end of first T state, it is going to be select the chip as well as register location. It's going to be select the chip as well as it's going to be select the register location. After T1 state, ALE is going to become 0. If ALE is going to become 0, you just remember in minimum mode configuration, if ALE is 0, what will happen? The latch is going to be not strobe, right? Strobe signal is going to be 0. That is the reason address channel is going to be closed, then data is going to be activated. That is the reason same 20 pins, lower 16 pins are acting like a data pins and higher 4 pins are acting like a status pins, right? So this lower 16 pins or this 16 lines to carry the data, right? So this, it shows the status of the what operation is going to take place. That means what, you already know S3 to S7 status lines will tell you whether by the time the processor is communicating with code segment, data segment, extra segment or stack segment. So it just show the status by looking into this particular pins carrying data. You can say the status of the operation. But lower 16 pins, or you can say that 16-bit data bus is used to pass the data, right? After this, what it has to perform, it has to select the some control signal. That means it has to out some control signal. Based on that data, whether it's going to be read or write. See here, if it is high, then what will happen? If it is high, this is the memory operation. If it is low, this is the IO operation, right? If the memory write cycle, that is the reason this is only coming to the picture. This is only coming to the picture. This line is only coming to the picture. For IO write cycle, this is going to become this one low, because this is high memory write cycle. Memory is going to be, this is the line is going to, that means what, it has to be high. Then whether it's receiving or transmitting the data, write means it's a transmitting data. That is the reason it is high only. Right? So reading is high. It is high only. Why? Because This is the write cycle. That is the reason write is going to be low. It's going to be low after T1 state. After T1 state, once it is act like a data bus, AL is low, it is act like a data bus, then write signal is going to be low. Whenever it's the write signal from the memory, data is going to be write into the data bus. Sorry, whatever the data is present on the data bus, that is going to be write into the external memory. That is going to write into the external memory, right? By that time, anyway, data is enabled on the data bus. That is the reason it is low. Up to T1 state, data is not available on the data bus. After that, data is available on the data bus. Alright. So this is the way this particular operation is going to be takes place. Look at once again. See, with respect to time, these all signals are going to be high or low. All signals are going to be high or low. Once AL is low during the T1 state, at multiplexed address and data bus is acting like address bus, as well as multiplexed address and status bus is acting like a address bus, right? By that time, this is high, this is receiving data only. That is the reason transmitting, writing means from the processor to the memory. It is I only. So it is read operation. No, that is the reason this is I only, right? So this is I only up to T1 state. After T1 state, this is going to be low. Once it is low, whatever the data present on the data bus, it's going to write into the external memory. After AL is 0, same multiplexed address and data bus is acting like a data bus, right? Here status, right? So by that time, processor is going to be place some data on the then 16-bit data bus, that is going to be passed through the bidirectional buffers and going to be stored in the external memory, right? So that is the reason this read signal is going to be 0. By that time, data is going to be enabled on the data bus. Like that, this particular signals are going to be make high or low with respect to this particular time period. After T4 state, once again, one data is write into the external memory. Then, based on the instruction, it may be memory reader or memory write, IO read or IO write. Next one, right? So like that, we need to understand this particular timing diagram and we need to draw this particular timing diagram. Alright. So thank you.